Hi everyone, this is the video lesson for 5.1 derivatives of exponential functions y equal to e to the power of x. Here's the warm-up. What is the derivative of y equal to e to the x? Y prime equals to e to the power of x. And as a side note, of course, you can always derive all these different cases, including this lesson that we're looking at, by plugging it back in to the first principle. So again, the first principle is when you take the limit as h is approaching 0 of f of x plus h minus f of x divided by h. And I'll leave that to you if you want to go back and kind of show this. Now, of course, this is a function where if you keep going and you find a second derivative, it is also e to the power of x. If you find the third derivative, again, it is going to be e to the power of x. If you took the fourth derivative, again, it's going to be e to the power of x. If you took the fifth derivative, it's going to be e to the power of x. And if you look at the pattern, if you kept going to the nth derivative, it is still going to be e to the power of x. Number 2, what is the derivative of y equal to e to the power of f of x? So again, this is very similar to number 1, and what you're adding on top of number 1 is the chain rule. So again, if y equals to e to the power of f of x, there are two major steps here. Step 1, when you find y prime, that's going to be e to the power of f of x. Step 2, you multiply by the derivative of the exponent, which is f prime of x. And again, that is the chain rule, which we have talked about from before. Example number 1, determine the derivative of each function. So again, if y equals to e to the x, y prime equals to e to the power of x. Part B, y equals to e to the power of 2x. So again, in this case, if you apply the chain rule, first you copy e to the power of 2x. Step 2, you multiply by 2. And 2 because it's the derivative of the exponent, which is 2x. If you write this with the coefficient at the front, y prime equals to 2 times e to the power of 2x. 1c, y equals to e to the power of x squared. Again, y prime equals to e to the power of x squared. That's step 1. Step 2, you multiply by the derivative of the exponent, which is 2x. Again, if you express this with the coefficient at the front, the final answer is going to be 2x times e to the power of x squared. Part D, y equals to x times e to the power of x plus 1. And again, recall the product rule. So again, we're combining a bunch of rules within the same example. And if you think about the product rule, this is when you have a function equals to the product of, let's say, f of x times g of x. So now, when you find the derivative, again, there are 5 steps here in the product rule. You differentiate the first, multiply by the second, plus you copy the first and you multiply by the derivative of the second. So now that you recall the product rule, in this case, y prime equals to, the first part is x. When you differentiate x, the answer is going to be 1. And you multiply this by the second part, e to the power of x plus 1, plus you copy the first part, which is x, and you multiply by the derivative of the second part, which is e to the power of x plus 1 times 1. Again, the 1 means you're taking the derivative of the exponent, which is the chain rule that we described from above. here comes the final answer. Y prime equals to, again, there's a common factor of e to the power of x plus 1 that goes to the front. In the brackets, it's going to be 1 plus x. Now, before we move on to example number 2, let's add a bonus one, 1e. Again, if y equals to e to the power of 2x divided by 1 plus e to the 2x, find y prime. And again, this is the quotient rule. You can press pause, try this first. When you press play again, I'll be right here. Okay, now that you've tried this, here are the 6 basic steps behind the quotient rule. Step 1, you can square the bottom. Step 2, you can copy the bottom to the top. Step 3, you multiply by the derivative of the top. And again, it's e to the 2x times 2, which I'm going to copy at the front. Minus, I copy the top, e to the power of 2x times the derivative of the bottom, which will be 2 times e to the power of 2x. So I hope you've tried it and you're connecting this with the answer at hand. Again, if you expand this, let's draw some arrows. If you expand this, 1 times 2 to the power, or 1 times 2 e to the power of 2x is going to be 2 e to the power of 2x plus 2 times e to the power of 4x. Again, remember, when you're multiplying the same base, you add the exponents, minus 2 times e to the power of 4x, all over. You can copy the denominator. When you collect like terms, you will notice that 2 e to the 4x minus itself, that will give you 0. So the final answer, y prime equals to 2 e to the 2x divided by 1 plus e to the 2x quantity square. Now again, I hope you did this right, and in case you need more to improve your skills, let's give you another bonus one. Now again, you try this first, and of course I'll take it up. So instead of finding y prime, let's say we're asking you to find f double prime of x. And this time, you're starting with f of x, which equals to e to the x times 4 minus x. So again, your goal is to find the second derivative. Press pause, try this. When you press play again, I'll be right here. Here we go. So again, I hope you've tried this, and now we can confirm if we are synchronized and if we're on the same page. So to find the first derivative, f prime, what you can do is expand this first. And again, some students expand this first, others would use the product rule. It's really up to you. So one approach is to expand this and make it 4 times e to the power of x minus x times e to the power of x. So now, when you find f prime, this equals to 4 times e to the x. Again, this second part that we're looking at, you're applying the product rule. And because we're applying the product rule, it's important to put a bracket so you can keep track of all the plus and minus signs. Again, you differentiate the first, which is 1. You multiply by the second, e to the x, plus x times e to the power of x. Now before we find f double prime, again, you can collect like terms. And if you look at this carefully, it's 4 times e to the x minus 1 times e to the x, which is 3 times e to the x minus x times e to the x. Now, again, if we don't want to find f double prime with this form, you can always put this in factor form just to show you the other approach. So the common factor is going to be e to the x, and in brackets 3 minus x, like that. Now we can find f double prime, and again we're applying the product rule. Copy the first, or differentiate the first. or maybe I'll do it the other way here. You can copy the first, differentiate the second, plus differentiate the first, copy the second. Again, it's up to you. For the product rule, you're adding, so either order would work. Quotient rule, on the other hand, will not, because you're subtracting, so order matters. F double prime equals to negative e to the x plus e to the x times, let's expand this. So plus 3 times e to the x minus x times e to the x. And now if you collect like terms, f double prime equals to 3 minus 1 is going to be 2, so 2 times e to the x minus x to the, or x times e to the power of x. There's a common factor of e to the x at the front, and in the second bracket, 2 minus x, just like that. So again, I hope you did the same thing, and we are synchronized. Let's keep going. Example number 2. Determine the equation of the line tangent of